Howdy and welcome back. So data representation. The first topic that we're going to get into today is going to be the binary number system. I know the overview looks a little cluttered. These slides are carried over from my days at Texas A&M University. I went into a bit more detail there, and then I kind of stepped back and settled on this as I think a good introduction to data representation. Though I did preserve the slides when this was a little more detailed, and you can see them in the appendix section. I put a lot of work into getting these kind of laid out on screen in a very hopefully accessible manner. So as you know, you're going through these, if you have questions, okay, we talked about binary addition. How does binary, subtraction, multiplication, division work out? Go ahead and just check it out in the appendix. I put together some, nice, well, in my opinion, nice kind of representations to walk you through the process. So let's go ahead and get into the binary number system. I wanted to first talk about some motivation for study to hopefully get you excited about this topic. And then in this video, after running through some motivation, I'm going to talk about binary numbers in the modern computers very briefly, and then we'll go ahead in the next video, get into the positional number systems, the binary number system, and then we'll continue to kind of break this section down into smaller and more tangible pieces. But motivation for study, let's go ahead and get into it. If you've programmed before, you may have had some surprises in the results of your computations. For example, consider that this really large number, I believe it's 1.5 billion, plus another really large number, again, I think this is 1.5 billion, evaluates to some really large negative number on my machine. And the question is, what's going on? This is a result that mathematicians would consider very wrong. And why am I observing it here? Well, what we will see is this is an implication of kind of how integer values are stored within the memory allocated to our programs. And by the end of today's lesson, you should understand what is going on in this particular situation. Another example that might have confused you, might have intrigued you, would be this one. Consider that 0.15 plus 0.15 evaluates to 0.299 repeating on my machine. Again, this is a result that mathematicians would consider very wrong. So what's going on in this case? Well, we're going to see that this is a consequence of how floating point numbers are stored as approximations within our within the memory allocated to them. So we'll get into this topic as well. And again, by the end of this lesson, you'll kind of understand what's going on in this first motivating example. And in addition to that, you'll also hopefully have some clarification and understanding as to what is happening in the second. So motivation for study, just continuing going down this pathway, the results that we observed are a reflection of the way that numbers are stored in computers. This can impact how our programs work. So it's going to be worth taking a bit of time to discuss the representation of data in the computer. And hopefully at this point, you're motivated to study this topic. Hopefully I did a good job building it up, maybe not, but we're going to get into it and hopefully you'll have some fun with it as I am here. So binary numbers in modern computers, again, I'm going to just run through this very quick and pretty much acknowledge that our memory is going to be stored as a sequence of ones and zeros somewhere out there in memory, and we'll go out there to retrieve, say, that integer value in your stored in your program, and it's going to be interpreted according to that sequence of what we'll come to know as bits to the base type, in that case integer, and we'll kind of get into that here moving forward. But what I really wanted to talk about on this slide was all information stored on modern computers is represented with numbers. Binary base 2 numbers are going to be used to represent these particular numbers in those modern computers. And this is because electronics in the computer alternate between two states, on and off, and sequences of these represent numbers, which in turn represent data. And in your computer architecture class, I believe you'll get, really kind of into this, but for the purposes of this course, this is kind of a sufficient level of understanding. We're kind of looking at it from 20,000 feet up in the air and taking it kind of for granted without getting into too much of how all of this kind of comes together into a functioning machine. But in due time, you'll learn that as you matriculate through our curriculum. So with that, I'm going to go ahead and move into the next video where we will discuss what a positional number system is, and then we will go ahead and introduce the binary number system. And kind of the remainder of this section is going to be very important to understand, because when we begin talking about data represented in the computer, well, we're going to be using the binary number system, and having that understanding will make those topics, those representations more tangible. So with that, I'll see you all in the next video.